Okay, so in this section, we are going to solve integration problems that involve the difference or sum of squares. So our goal is to solve integrals that contain a squared minus x squared, a squared plus x squared, or x squared minus a squared. So we're going to see these things inside of an integral, and they are going to trigger a memory response of exactly how to solve these problems. The only way they're going to trigger a memory response is if you can remember these original integrals. So let's recall these integrals. The first one was the integral of dx over the square root of a squared minus x squared is the sine inverse of x over a plus c. So you get, this is the integral formula where your result is an inverse sine function. If you take the integral of dx over a squared plus x squared, then you get 1 over a, the tan inverse of x over a plus a constant. So any integral of this specific form gave you a inverse tangent. And then any integral of the form dx over x, the square root of x squared minus a squared, gave you 1 over a, the secant inverse of the absolute value of x over a plus a constant. So you got the inverse secant. So way back in the beginning of the course, I would say probably around the second or third week, we were able to, well, actually later than that, because we found the derivatives of these trig functions first, and then we were able to later on find the integrals that gave us these back. So if you have a solid recollection of these integrals, going into this next section will not be too difficult. Okay, so why? All right, so well, the first transformation is if I have an integral that has a squared minus x squared somewhere in the integral, then my transformation will be theta is the sine inverse of x over a, or x over a is equal to the sine of theta. These two equations are the same. One just solves for x over a, the other solves for theta. Okay. If your integral contains a squared plus x squared, notice just like this integral, then the transformation we're going to use is theta is the tan inverse of x over a, or another way to write it is x over a is the tangent of theta. So this is the second form. And don't worry, I'm going to give you time to write all this down as we keep going. And then the third one is if you have x squared minus a squared in your problem, then we're going to use theta is the secant inverse of x over a, or x over a is the secant of theta. So I will give you a few seconds to write these down. I know you know the other integrals, so I'm going to go ahead and start here. Okay, so these are the transformations that we are going to use in this section. Any questions so far? Does anybody not understand how we get from theta is equal to the sine inverse of x over a to x over a is the sine theta, or to go back? Everybody understands how to go back and forth between the two equations? Okay, hearing no questions. Okay, so let's start with the first one. Oh, so let me go back to my little picture of my bicycle here. Okay, can somebody give me what's the difference between these two bicycles? Anybody? That's not
One
even
is
hard.
broken.
One's
Yeah.
closed.
Okay, so one is in pristine condition and the other one's all tore up and broken. So if I let you borrow my bicycle, I want it back exactly the same way I gave it to you. Do not give me a bicycle that looks different. I don't care what it looks like. I want it to look exactly the way I gave it to you. The reason why I have this picture here is because all the problems are going to be given to you in the variable of X. We will then switch to the variable theta. If you end your problem in theta, that's like giving somebody back a broken bicycle. It's not the way they gave it to you. All the problems have to end in X. Okay, so that's what this little bicycle thing is here. Okay. All right, so first problem is this one. Okay, so here is our first problem. And our first problem appears to have an a squared minus x squared in the problem. Okay, so as you see a squared minus x squared, then what are we going to use for a? So obviously in this problem, a is going to be 1. Okay, so here a is 1. A squared is 1. So that implies a is 1. Okay, and I have 1 minus x squared. So now we're going to draw this triangle. So let me go back and grab the triangle that I need. All right, so here's my triangle. So the transformation we're going to use is theta, is the sine inverse of x over a, or x over a is equal to the sine of theta. So let's stick theta. I hope you guys know your trig functions very well. We're going to stick theta inside here. So there's theta. And if x over a is the sine of theta, that means this is x and this is a. So x over a is the sine of theta. And so then that means that right up underneath here is the square root of a squared minus x squared. So that is the triangle that associates with this problem. All right, 3 different triangles, we'll do them all. Okay, so in our problem, we know a is 1. Okay, so I can write that this is equal to 1. And that this side is simply the square root of 1 minus x squared. Okay. All righty. So now I'm going to start with exactly that. So x over a is the sine of theta. So in our case, a is 1. So we get x is just the sine of theta. Okay, what's dx? Well, dx is the derivative of that. That is the cosine of theta, d theta. Any questions so far? All right, well, that's good for me because now my dx is taken care of. Here's dx. Here's x. So the only other thing I need to figure out now is what is the square root of 1 minus x squared. So the square root of 1 minus x squared, you can either use the table if you want, or you can actually figure it out. It is the square root of 1 minus x, so that's sine squared. And 1 minus sine squared is cosine squared, and the square root of cosine squared is cosine. Because we're assuming this angle is between 0 and pi over 2. Okay, another way you can do that is to actually use the triangle, that if x over a, that's the sine of theta, then the square root of x minus 1 of 1 minus x squared over 1 is the cosine theta. So you can find this several different ways. Okay. So now we can make a complete substitution. All right. All right, so a complete substitution. All right, so let's go back to my integral. So I'm going to bring my integral down here. And I'm going to see that in the place of x cubed, what is x cubed? Well, x is sine theta. So I'm going to get the sine of theta cubed. Dx is cosine theta d theta. And that is over the square root of 1 minus x squared, which we have shown is cosine theta. So this now just becomes the integral. Cosine of theta and cosine of theta divide out. So I get the integral of the sine cubed of theta d theta. Okay, so now I'm here. So my question to you is, how do we integrate sine cubed? All right, so let's go back to the previous section. We're integrating when one of sine or cosine is odd. The power is odd. So how do we integrate this?
Would it be sine 2 theta times sine theta?
Okay, almost. Sine squared theta times the sine of theta d theta. Now, we pulled one off. So when you pull one off, you have to throw the rest away, right? Okay, so that means this sine squared has to become 1 minus cosine squared theta. And then I have the sine of theta d theta. Okay, so now I have a u substitution. So I'm going to let u equal cosine of theta. And du is going to equal negative sine of theta d theta. So the sine of theta d theta is going to be negative du. Everybody with me so far? Did I leave anybody behind? Okay. So notice how we went from x to theta and theta to u. So we went from x to theta and from theta to u. So that means obviously we got to go backwards, okay? All right, so this becomes the integral of 1 minus u squared. The sine of theta is negative du. So this is the integral of u squared minus 1 du. So that is 1/3 u cubed minus u plus a constant. Any questions about that? Okay, so now we got to go from u back to theta. Okay, so this is equal to 1/3 u is the cosine of theta. So that's the cosine cubed of theta minus the cosine of theta plus a constant. Okay, so now we're in theta. So now we have to go from theta back to x. So we go back up here. And what is the cosine of theta? Ah, here it is. The cosine of theta is the square root of 1 minus x squared. So this becomes 1/3. Then I'm going to get the square root of 1 minus x squared. That has to be cubed minus the square root of 1 minus x squared, because that's cosine, plus a constant. Okay. So this answer becomes 1/3 1 minus x squared to the 3/2 power minus 1 minus x squared to the 1/2 power plus a constant. Okay, so my bicycle started in x, I'm back to x. All right, so let's recap. I'm gonna go back. So we started with a squared minus x squared. We knew a was 1. We also knew that x over 1 was the sine of theta. So we got this. We took its derivative, which gave us cosine theta. Then we looked at what is the square root of 1 minus x squared. Well, it's 1 minus the sine squared, which is the cosine squared, and the square root of cosine squared is just cosine. Okay, so we're good. Then we plugged everything in, so we did a complete substitution. So x cubed was sine cubed theta, dx was cosine theta d theta. The square root of 1 minus x squared was cosine theta. The cosines canceled, we got sine cubed. Now we're back in section 3.2. We're going to pull off one sine and throw away the rest of the sines and make them cosines. So now u is cosine, du is negative sine, sine is negative du. Plug that into the problem. The negative flips the sign of that and makes it u squared minus 1. I integrate 1/3 u cubed minus u plus a constant. Now I got to take u and go back to theta. So I put in what u is. Then I have to take theta and go back to x. So in the place of cosine of theta, I put the square root, and this is my answer. Okay. So this is equal to 1/3 1 minus x squared to the 3/2 power minus 1 minus x squared to the 1/2 power plus a constant. It's a solution to a problem. I like to make them in blue. There we go. Okay, any questions? All righty. Second problem. Okay, so problem number 2 looks like this. And as I said, we'll use this stuff a couple of times today. So whenever you have a squared plus x squared, you take and you use theta is the tan inverse of x over a, or x over a is the tangent of theta. Okay, any questions about that? This reminds us of the tan inverse integral here. So the tan inverse integral had a squared plus x squared. So we're going to associate that with the tan inverse. Okay, I'm gonna get my little triangle. Okay. So as we can see, a squared is 4. So a is 2. Okay, so we're going to use the fact that x over a is the tangent of theta. All righty. So now x over a, so in our case, that's x over 2, is the tangent of theta. So here's theta, here's x, and here's 2. That makes the tangent. That means that this side up here is 4 plus x squared. Okay. All righty. So now we get x is equal to 2 times the tangent of theta. All righty, that's good. So dx, we're going to need that, is 2 times the secant squared of theta d theta. Okay, what am I going to do now with this 4 plus x squared? All right, well, let's see what 4 plus x squared is. Well, 4 plus x squared is 4 plus x squared happens to be 2 times the tangent of theta squared. So that's 4 plus 4 times the tangent squared of theta. Okay, we're getting somewhere. Factor out the 4, and that leaves 1 plus tangent squared theta. And we remember from the formulas I told you to remember yesterday that 1 plus tangent squared is secant squared. Okay, so 4 plus x squared is 4 times secant squared theta. All right, so that looks pretty good. So I think we're ready to substitute because we have dx and we have 4 plus x squared. And that's the only thing in the problem. So there's nothing else to find. All right. So we're going to do a complete substitution again. Okay, so when we do the complete substitution, okay. This is getting on my nerves. That's what I want. Thank you. Okay. dx. So this is the integral. Dx is 2 times the secant squared of theta d theta. So that's the first part. And then in the denominator, I'm going to get 4 times the secant squared of theta squared. Okay. So this becomes the integral. I have 2 over 16. So that's going to give me 1 over 8. So let's move the 1 over 8 to the outside. The integral, I have secant squared theta in the numerator, and in the denominator, I have secant to the 4th of theta. Okay, let's keep going. So this now becomes 1 over 8. And now this is just the integral of 1 over the secant squared of theta. But the secant squared is 1 over cosine. So this becomes 1 over 8, the integral of the cosine squared of theta d theta. Okay, how do you integrate cosine squared? How do you integrate cosine squared? Okay, well, while you integrate cosine squared, I'm going to take the roll. How do you integrate cosine squared? The powers are even.
Would it be cosine of x times sine of x?
Okay, we have to use the double angle formula, but thank you for trying. We have to use 1/2 times 1 plus the cosine of 2 theta d theta. So this becomes 1 over 16. And then when we integrate, we're going to get x. Sorry, no, we're not. We're going to get theta plus 1/2 plus 1/2 the sine of 2 theta plus a constant. And so now I have to give you a new rule. The sine of 2 theta is 2 the sine of theta cosine theta. Okay, so here's a new rule you have to know. All righty. Okay, Max. All right, so here's a new rule you have to know. So this now becomes 1/16 times theta plus, when I put in 2 sine theta cosine theta times a half, I just get the sine of theta times the cosine of theta plus c. Notice I didn't have to do a U substitution on this one. This one was an easier problem. But now I have to go back to theta, and this is why I drew my triangle, because I need to know what theta is. So what is theta? Okay, well, here it is. Theta is the tan inverse of x over a. So theta is the tan inverse of x over 2. So that's theta. How about the sine of theta? Well, the sine of theta is going to be opposite over hypotenuse. So the sine is going to be x over the square root of 4 plus x squared. And the cosine of theta, notice I've gone back to my triangle. So the cosine of theta is 2 over the square root of 4 plus x squared. Okay, so now I can complete my problem. This is going to equal 1/16. And then theta is the tan inverse. I'm going back to x of x over 2. Plus, when I take the sine times the cosine, I get 2x over, and when I multiply those, I get 4 plus x squared. And there's my answer. Okay. Questions? Questions? Okay, so we learned a new formula out of this one. That's the sine of 2 theta is 2 times the sine of theta cosine theta. Okay. All right, we already did a sine and a tangent, so we got to do a secant. How do I know it's a secant? Because it is x squared minus a squared. Okay. So here we have, for this one, we have x squared minus a squared. So clearly a squared is 25. So a is 5. All right. And we're going to have x over 5 is going to be the secant of theta. So x is going to be 5 times the secant of theta. So now I need to get my little trusty triangle. All right, so here's theta. And it says the secant is x over 5. So the secant is 1 over cosine, so that's x over 5, which makes this side over here the square root of x squared minus 25. Okay. All right, so let's see. In this problem, I need a x, a dx, and a x squared minus 25. Okay, so I have x. Dx is 5 secant theta, tangent theta, d theta. Okay, that's good. And then the square root of x squared minus 25 is the square root x squared is going to be 5 secant of theta squared minus 25. So we're getting somewhere. So that looks like the square root of 25 times the secant squared of theta minus 1. But oh, secant squared of theta minus 1 is just tangent squared. Okay. So this is, we can already see there's going to be a 5. And then tangent squared is going to give us 5 times the tangent of theta. All right, so the square root of x squared minus 25 is 5 times the tangent of theta. And I believe that. Okay, so now we have everything we need. All righty, so we're going to do a complete substitution again. So this is going to equal the integral, the square root of x squared minus 25. Well, that's 5 times the tangent of theta. And d theta is 5 times the secant of theta, tangent of theta, d theta. So that's dx. And then x is 5 times the secant of theta. Okay. All right, complete substitution. So now I can divide out this 5 and this secant theta and get this is 5 times the integral of tangent squared theta d theta. And if you remember from when Mr. Piaget taught, we trade out tangent squared for secant squared of theta minus 1 d theta. So that's 5 times integrate secant squared. You get the tangent of theta minus theta plus a constant. Okay, so I need to go back to my problem. So the tangent of theta is opposite over adjacent. Okay, so I can handle that. That's good. And then theta is the secant inverse of x over 5. So I can handle that too. All right, so therefore we get 5. The tangent of theta, we said, was the square root of x squared minus 25 over 5 minus theta, and theta is the tan, isn't it? Theta is the secant inverse of x over 5. Plus a constant. Theta is the secant inverse of x over 5 plus a constant. Okay, you guys are all too quiet. What's going on? I thought you guys would like this. Okay, questions so far? You guys are absolutely too quiet. Absolutely too quiet. Is it the formulas? What's the problem?
When it comes to the sine 2 theta, or like the two theta problems, I know it's like a little bit off topic, but I was wondering if does the formula that you recorded earlier does that apply to how to say will that is it just a general formula that can be applied to multiple problems, or
This,
if it's
the sine of 2 theta is an identity. And anytime you integrate the cosine of 2 theta, you're always going to get 1/2 the sine of 2 theta, and you're going to need to be able to use that formula to bring it back to x. So you're
Okay.
going to need 2 theta, sine of theta, and the cosine of theta to bring it back to x. And then you're going to have to go to whatever triangle you're using for your particular problem, because it may change. So you're going to use it for whatever triangle. And so for here, I went back to this triangle and I found the sine and the cosine. So yes, this formula is a very important formula. It will surface many, many times in many of these problems. Max, I actually moved the 5 outside the integral. That is correct. And then at this last step right here, where I had the tangent was over 5. I multiplied, I put it back, I distributed it. So the 5 multiplied by the 5 in the denominator, divided out. And then it multiplied by the secant inverse of x over 5. Any other questions?
Not really a question, but like the most difficult part of all this is just memorization.
Yeah.
Because like every day I feel like new things are being added, and then like I'm like have to memorize like the whole exam when it comes to it. It's just hard.
Okay, so I agree, which is why I go back to the 3x5 cards, is that these help. I mean, You sitting around waiting on your friend to come. You're supposed to be meeting for dinner at 5 and it's 5:10. Whip out those 3x5 cards and just go pop. Integral of sine, cosine, integral tangent, integral tan inverse, integral of so-and-so. What's the trick? What's the half angle formula, double angle formula, sine, formula for sine 2 theta, the derivative of log, derivative of exponent, integral of integrals. And before your friend comes, you done gone through 15, 20 cards and you start to know it. And the other thing about making a review sheet, when you create a review sheet, you are teaching the material to yourself. You learn it. It doesn't help if somebody else creates a review sheet for you. It helps if you do it because that's what reinforces your learning. Okay, no more preaching. Next problem. Okay. Next problem. Can anybody recognize this one? This one's a little tough. Okay.
Isn't it for the inverse secant?
Okay. What makes you think I know what makes you think inverse secant. This X down here, doesn't it?
Yeah.
Okay, but that X is a disguise. He's a trick person in disguise. Notice that inside the square root, I have the constant comes first. So this one's going to be a little bit different. This one's going to be an a squared minus u squared one. So we're going to do a squared minus u squared. Okay, so here u squared is 9x squared. So u is 3x. All right. A squared is 16. So A is going to be 4. Okay. I need dx. Dx is going to be 3 du. Okay. So far, so good. And then x is u over 3. So x squared is going to be u squared over 9. Okay. All righty. Let's see what we have here. We haven't even done the trig part yet. We're just still dealing with this. All right. So the integral dx is where? 3 du. x squared is u squared over 9. And then this becomes the square root of a squared minus u squared. So this now becomes, I'm going to divide by that. So I'm going to get 27 times the integral of du over u squared times a squared minus u squared. All right. Okay. So now u over a is going to be my sine inverse of theta, or theta is that is wrong. U over a is the sine of theta, or theta is the sine inverse of u over a. So let's go get the triangle. Okay, so u is equal to, what was a? I think a was 4. 4 times the sine of theta. And du is 4 cosine theta d theta. Okay, so here's theta. So u over 4 is the sine of theta. So this side is 16 minus u squared. Okay, what else do I need for my problem? Because here's my new problem. Let me write my new problem first. Why am I doing this problem this way? Because, no. All right, so this is a new problem. This is du over u squared, and then the square root of 16 minus u squared. All right, that's the new problem. All right. So the only thing we need is to find the square root of 16 minus u squared. Okay, so the square root of 16 minus u squared is the square root of 16 minus 4 sine of theta squared. So that is the square root of 4 times 1 minus the sine squared of theta, which is the square, which is 2. And 1 minus sine squared is cosine squared. Under the square root just makes cosine. All righty, so now we have everything. So our original integral is the integral is 27, the integral of du, which is 4 sine theta, divided by u squared, which is, no, I'm sorry, du is 4 cosine theta d theta. And then u squared is 16 sine squared of theta. And then the square root of 16 minus u squared is 2 cosine of theta. So this gives me 27 times the integral. I'm going to have 27, and then I'm going to divide out. I have 4 over 32, so that's going to give me an 8. Okay, the cosines are going to divide out. And then over sine squared is cosecant squared. D theta. All right, any questions so far? I want to go back and recap. We took the original problem, which was 16 minus 9x squared. We changed it to 16 minus u squared. And so therefore we have a squared minus u squared. Okay, so we knew u squared was 9x squared, so therefore u was 3x. A squared is 16, so a is 4. So dx was 3 du, so therefore x was u over 3. We got that from over here. And x squared is u squared over 9. So now we can make a complete substitution. Dx was 3 du, x squared was u squared over 9. And this became the square root of a squared minus u squared. So this is our new problem. So we rewrote the new problem as 27 integral of du over u squared 16 minus u squared. So now we have this triangle. So u over a is the sine of theta, and theta is the sine inverse of u over a. So if I really want to write this, this is u over 4 is the sine of theta. So u is equal to, I wrote it down there, 4 sine theta. Du is 4 cosine theta d theta, and then the square root of 16 minus u squared became 2 cosine theta. That's not right. That is not right. I see a mistake. This should be a 16, and this should be a 4. That's why I have to recap sometimes. All right, so therefore this should be a 4. And then this should be a 16. Much better. Okay. How do you integrate cosecant squared? How do you integrate cosecant squared?
The cotangent.
Okay. Negative 27 over 16, the cotangent of theta plus C. Okay, where do we go from there? Where do I go from there? I feel like I still made a mistake. I still shouldn't have that many. I did make a mistake. Right here, this should be, yeah, that's what happens when you switch variables. This should be du is equal to 3 dx. So therefore dx is 1 over 3 du. Okay, that's what went wrong. This should be 1 over 3 du. And so therefore, this should only be a 3 out here, not a 27. Okay, good. Let's change this to a 3. And then this should be a 3. And then it should be 3 over 16. All right, so what's the cotangent of theta? You see the cotangent of theta? The cotangent of theta is the square root of 16 minus u squared over u. So this is negative 3. The square root of 16 minus u squared over u. But remember the bicycle, it has to go back the same way it came to me. And u was 3x. The square root of 16 minus 3x squared is 9x squared over 3x over 16 plus a constant. And the answer is negative square root of 16 minus 9x squared divided by 16x plus a constant. And that's it. Okay. So the difficult parts, knowing the integral of cosecant squared. Another difficult part was switching to u. A difficult part here was integrating tangent squared. We learned that last section. Another difficult part, switching to sine 2 theta. to 2 sine theta cosine theta. And I think those were the major difficult parts of today. Okay.